Alright guys, so what we're doing today is finishing up the lesson from yesterday, finding the roots of complex numbers. Now the theorem that we had yesterday for finding the roots, I do have a pen.
Is Allie Shelley in here?
Yes, but I need her for this hour.
Okay.
So z to the n is equal to the nth root of r, parentheses, cosine of theta plus 360k over n plus I sine of theta plus 360k over n. Where n is the root, k is going to be our value from 0, 1, 2, all the way up to n minus 1. And we have r, and theta. And anytime we're finding the roots, we do need to get it in polar form, in a trig form. So here, we're taking 1 plus 0i and rewriting it. Whenever a term is not listed, it's understood to be 0. So here, since it's just 1, we have 0i. And then vice versa is true as well. Now, r values the square root of a squared plus b squared, which is really just going to be 1 squared, and the square root of 1 squared is just 1. Theta is going to be tangent inverse of b over a. And for any of these here, as I said before, it's really thinking of it also in terms of the complex plane or the Cartesian coordinates, x, y, where the point's at. Because we could go through and do tangent inverse of 0 over 1 to try to find that angle, but on a graph, it's going to be right there. It's going to be on the positive x-axis, which is 0 degrees. If we use the calculator, clear that out, say second tangent inverse of 0 over 1, it'll tell us it's 0 degrees. So kind of using both is sometimes helpful. And if it does work out that we are on one of the axes, the positive or negative x, positive or negative y, those angles are kind of easy to figure out. We don't really need to use the tangent inverse. So we have these two here. Now, we also know that k for us here, well, we can say n is 6, because we're finding 6 roots, which means k is going to be 0, 1, 2, 3, 4, 5. So we're going to find 5 of them. Now, luckily, I did give you an entire page to fill this in, so you should have more than enough room. And I will keep track of them on the sideboard too. Now, the first one we'll start off with is the 0, where the value of k is 0. Now, we have the nth root of r. So n is 6, and r is 1. This is really going to be the last time we write this, because, well, the 6th root of 1 is what? 1. Really, no matter how big the root we take of 1, it's still just 1. It's one of the nice ones. Parentheses, cosine of 0 plus 360 times 0 over 6 plus I sine of 0 plus 360 times 0 over 6. And again, I chose to do degrees. You can do it in radians as well. You can do radians or degrees. And if the problem does give it to you in radians, a radian measure, you can convert it to degrees and work it out in degrees. Now we already said the sixth root of 1 is just 1. I don't have to rewrite it back in. So really what we have is cosine of 0 times, or 0 plus, do this here, 0 plus 360 times 0 over 6 is, surprise, surprise, 0. Cosine of 0 plus I sine of 0. And at this point here, we can calculate these. Cosine of 0 degrees is 1. Sine of 0 degrees is 0, which just tells us that z of 0, our first value, is 1. Questions on this here? We have 5 more to do. Now, some of the things we can look at, especially with this here, is seeing what's changing. Well, we know for certain that the nth root of r, let me get a highlighter out. This here is just 1. So I really don't need to relist it every single time, multiplication of 1. It's just going to be our cosine and sine. Now, when we look at, let's get the highlighter, this here. Well, for certain, we know that both of these are going to be the same, yes? Is 0 adding anything to this, our initial angle? Well, no, it's 0. So really what I'm left with in both of these cases is cosine of 360 times k over n. The 360k is all that's really going to be left in the numerator because the angle is 0, so that's really what we have left, plus I sine of 360 times 1 over 6. Luckily, this one here is not that bad. 360 times 1 is just 360. And 360 divided by 6 is going to be 60. So we can look at cosine of 60 degrees and sine of 60 degrees. 1/2 square root 3 over 2. So 1/2 plus square root 3 over 2 I. Questions on this so far? Well, z sub 2 is just going to be our cosine of 360 times 2 over 6 plus I sine of 360 times 2 over 6. And again, at this point, we can plug this into the calculator. So we have cosine of 120 plus I sine of 120. We already knew 360 divided by 6 is 60. So we're just multiplying by 2 now. 60 times 2 would give us 120. And again, we can come back over here, cosine of 120, sine of 120. One half plus square root 3 over 2 I. questions on this so far? All right. Z is a 3. So now we have cosine of 360 times 3 over 6 plus I sine 360 times 3 over 6. Now at this point, again, we can plug 360 times 3 over 6 in the calculator, and it would give us 180. Cosine 180 sine. So we get -1 and 0, which is just really telling us that this is -1. Okay. Any questions on 1 through 3? Are we ready for number 4? So we'll have cosine of 360 times 4 over 6 plus I sine of 360 times 4 all over 6. And again, if we do this here, we're just going to find out that cosine is going to be multiplied by 240 plus I sine of 240. And again, we can plug it in the calculator. Cosine 240 sine. So -1/2 negative square root 3 over 2. And the last one, Z5, is going to be cosine of 360 times 5 over 6 plus I sine of 360 times 5 over 6. It's going to be cosine of 300 plus I sine of 300 degrees. She's going to tell us that we have 1/2 minus square root 3 over 2 I. And that's really it. So our values, Z0 was 1, Z1 was 1/2 plus square root 3 over 2 I. Z2 was -1/2 plus square root 3 over 2 I. Z sub 3 was -1. Z sub 4 is -1/2 minus square root 3 over 2 I. And Z sub 5 is 1/2 minus square root 3 over 2 I. And if we look at a Cartesian coordinate, or the complex coordinate plane, we'd have a point here, 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 here. And those aren't exact values because doing square root 3 over 2 would probably be a little bit further out, but we do get 6. And if you notice the repeated of values, that's not uncommon. Because if you look at the ones we did yesterday, pretty much all of those had a repeated value, a symmetry of some kind. Any questions on this here? Any question on anything we've done so far? Yep. Do we need to see another example of something like this here? Because most of this here is really just utilizing that formula, plugging the numbers in, and just continuing that process over and over again. Same with these here. This one here is a little bit nicer because we don't have to find r and we don't have to find theta. They already gave it to us. So if we looked at this here, r is 64, theta is 5/3. N in our case is 3 because we want the cubed root. And our values of k are going to be 0, 1, 2. So we're going to take 3 of them. I'm going to go on and show you this here so that we do see 1 in terms of pi instead of everything in degrees. It doesn't change anything at all. It's just now we're turning in pi instead of just a single number. So we can start off with z0 is equal to the cubed root of 64, parentheses, cosine of 5/3 plus 2 pi times k over n. Ran out of room, so I just went on and simplified the fact that 2 pi times 0 is indeed 0. One thing that is nice, the cubed root of 64 is 4. So for z1 and z2, we won't have to rewrite the cubed root of 64 anymore. We can just rewrite 4. So really, if we wanted to, I could have checked to see what the cubed root of 64 was. If it's 4, I could have started with that. Cosine 5/3 plus 2 pi times 0 over 3. We say pi over 3 plus 2 pi times 0 over 3. 5/9. So on the test, this is as far, again, as I'd make you take it. It's in polar form. This is the answer. Because there's a good chance, bring the calculator up. Now, again, we're in radians, so I need to change the calculator over to radians. And we can say cosine of pi over 9. Okay. That's already telling me these aren't going to be nice numbers. And if that is the case, and we're going to 3 or 4 decimal places, I'm going to show you this here with the graphing calculator also. Because the TI-30XS is nice, but it doesn't deal with complex numbers. So there's a good chance what we can do is 4 parentheses cosine of, I can find pi, pi over 9 plus I sine equals enter second pi over 9. I can type the whole thing in to get an answer. Now, it's not going to give me the correct answer if I just hit enter because the calculator is in degrees, not radians. So I do need to fix that first. Round to 3 decimal places. So instead of doing each one individually, I did the whole thing at once. So here, 3.759 calculator, plus 1.368i. And our next one's going to be pi over 3 plus 2 pi times 1 over 3 plus I sine of pi over 3 plus 2 pi times 1 over 3. Questions on this so far? Give you all a second to write that out. Now I feel at this point, you all being able to simplify pi over 3 plus 2 pi all divided by 3 isn't going to be too bad. You can do that just in the calculator. TI30XS will do it, yes? Now, most likely, if one of them gave us a decimal number, all of them are going to give us a not nice decimal number. Why not make this easier on ourselves? Because we can come back in here. I'm going to go to the first one here. Alpha y equals enter. Because we have pi over 3 plus 2 pi times 1 over 3. I'm just plugging it in as we have it. Then on the next one, I can do the exact same thing. Alpha y equals enter. Second pi over 3 plus 2 pi times 1 over 3. Now it might seem odd I put the 1 in parentheses. I just did that at this point so that when we do the next one, it's going to change from 1 to 2. Negative 3.064. Plus 2.571i. Questions on how we found this here? Are you ready to find the next one? And at this point here, especially on the homework, I'm not going to make you rewrite every single one of these out. Because what we can do here is now that I have that typed in, is I can come back and reselect this. Because the only difference in form from one to the next is that K changes. So really just changing those two numbers from 1 to 2, enter, and there's our last answer. Negative 0.695 minus 3.939i. Now this one here, we really don't have a nice repeated number or repeated setup, but that's fine. Some of them will, some of them won't. Any questions on any of this here? Now we do have these two here, these last two. They're not any different. And we'll look at one of these here because they're both cubed roots, same exact thing. Now the main difference between this and what we had before is that we have to solve it. And they didn't say take the cubed root, take the nth root of this here. And when I say solve, really it's just getting whatever the variable, because there's only going to be one variable. And then the rest is either going to be numbers or complex terms. So really we're saying x to the third is equal to 1 minus I. So what this is saying and what this problem is saying is that n is 3. We're wanting to take the cubed root of this. K, in our case, is 0, 1, 2. R is going to be the square root of 1 squared plus negative 1 squared, which is the square root of 2. Not nice. And theta is going to be tangent inverse of negative 1 over 1. Which is not 7 pi, right? 7 pi over 4, or, let's see here, that would be 315. Because we can say, go back to degrees. Second tangent inverse of negative 1 divided by 1, negative 45, 315. Okay. Now again, I did jump through that to get here. Now, it told us that tangent inverse of negative 1 over 1 is negative 45 degrees. And thinking of the plane, complex plane, negative 1, or 1 negative 1 is in the fourth quadrant. So to get the correct angle, I added 360 to it to get our angle. Because it is just telling us that this angle here is our negative 45. So this angle here is 315. Does that make sense how we get there? Now, most likely, I have a feeling you would rather prefer to do these in degrees over radians. Just as we saw in the last one, we get fractions in fractions, especially in the formula. And I like avoiding fractions in fractions if I don't actually have to do it that way. Now we can use our formula. Z sub 0 is equal to, since we're taking the cubed root, the third root of r, which is square root of 2, times cosine of, here, 315, plus 360 times 0 all over 3, plus I sine of the exact same thing. Ran out of room. Now the cubed root of the square root of 2 is going to end up being the sixth root of 2. An extra sheet. And this is going back to our nth root of a to the x is equal to a to the x over n. So the cubed root would be rewritten as the 1/3 power, square root's 1/2. Powers and powers multiply, so 1/2 times 1/3 is 1/6. which is just telling us that we have the sixth root of 2. It's almost working out that when we have this multiple root, we can multiply the indexes together to get it. And that's actually going to work out. Because if we did this step by step, it's just saying that we have a to the 1 over b to the 1 over n, which is a to the 1 over bn, which is the bnth root of a. The only way it would differ is if a actually had an exponent that would simplify one of the roots down. So, 6th root of 2. Now, I will come over here because 315 plus 360 over 0. 315 plus 360 times 0 all over 3. So we get 105. This is nice and not nice all at the same time. Because the 6th root of 2 is not a nice number. Cosine and sine of 105 are not nice numbers. Well, they are and not at the same time. There are half angles. So we can still do this in the graphing calculator, and especially on the homework, if we know what we're going to get. So 6 math down to the 5th one, 2 parentheses cosine alpha y equals enter 105 plus 360 times 0 over 3 parentheses plus I sine alpha y equals enter 105 plus 360 times 0 over 3 close parentheses, close parentheses. Because if this was on the homework assignment, I'm going to type the whole thing in. We're going to get decimals and we're going to have to round. If it's on the test, well, we already have the answer. The 6th root of 2 times cosine of 105 plus I sine of 105, I would move on. So here, we get 0.919 plus 0.644i. Yes, thank you. $105 was what we simplified it to. This is the correct answer. Now, you're wondering probably why there was only 3 decimal places and not more. I did that on purpose, and I'll show you that here. In mode, if you've ever wondered about float, if it says float, it's just approximate the decimal out as far as the calculator can show. I said 3, which is telling the calculator to approximate it out 3 places. Because if we wanted to say 4, I could select 4, so I can quit here, and it'll give me 4 spots after the decimal. So, something nice to know. So, our first value is negative 0.291. plus 1.084i. Now we have two more values, and especially if this is on the homework, we can call this back down and replace 0 with 1. 1. Negative 7, or negative 0.794. Funny enough, it actually worked out that both values were the same. And last one. 2. 2. 1.084 and 0.291. That's kind of nice. If you notice, the values of A and B for Z0 and Z2 flip. I think that's kind of neat. But those would be your answers. I mean, there's different shortcut ways we could have done this. We could have, instead of, and when I mean shortcuts, it's really manipulating the uses of different parts of the calculator. Because what I could have done is said 0 store x, so x is 0. And when we type this in originally, instead of putting 2 or putting a number there, I could have put it in as x, and there's our first value. Yes? Then I can go 1 store x, 2 store x, another way to do it, just makes it easier, manipulating the use of the calculator. But that is it. Any other questions on this here? And that is the last assignment of trig.